this last video, we will finish up solving trigonometric equations, but now using identities. So here we're going to have multiple different types of trig functions, and we want to make sure that we make them into just one. So here we want to solve the trig equations in the interval from 0 to 2 pi. So the first step to do is here we have sine squared x minus cosine squared x minus sine x equals 0. So what we want to do is that we want to make everything into just one trig function. So we're going to make this cosine squared x into a sine. So how do we do that? So we have sine squared x. This guy's going to be minus. So what trig function will help me make this into a sine? Well, the Pythagorean identity. So that's going to be 1 minus sine squared x. And then you have minus sine x equals 0. So I'm going to distribute this negative. You're going to get sine squared x minus 1 plus sine squared x minus sine x equals 0. Now I can combine these two together. That's going to give me 2 sine squared x. Then you have a minus sine x, then a minus 1 equals 0. Okay. All right, so now what we want to do is we want to try to factor it. So let's see if we can even factor this guy. Okay, so you're going to have a 2 and a sine here, and then a 1 and a 1. Now this guy's going to be negative and this guy's going to be positive. Okay, so now what you're going to have is 2 sine x plus 1 equals 0, and then sine x minus 1 equals 0. Okay, so for this guy, you're going to get sine of x equals negative 1/2. So what is x going to be? So negative 1/2 is in the unit circle. So let's look for negative 1/2 for sine. So negative 1/2. Let me get rid of all this. Okay, so negative 1/2. So for, wait, what was it? Negative 1/2 for sine. Okay, so negative 1/2 is going to be here. So that's 7 pi over 6. And then here, 11 pi over 6. 7 pi over 6 and 11 pi over 6. So that's the first ones. And now here, sine of x equals 1. So what angles am I going to get 1? So if I look at this, the only one that you get 1 is here, which is going to be at pi over 2. Okay, so that guy is going to be equal to, what happened? Pi over 2. Okay, so these are my solutions for that guy. Okay, good. All right, so now this one, okay, so now this one we kind of have to think about it. Well, first of all, we have the 2x and then this sine x, so that's not quite a quadratic, you know, so because there's no squared. So we got to think about, well, sine 2x is basically a double angle. So what is a double angle formula for sine 2x? Well, that guy is just 2 sine x cosine x. Then you have a minus sine x and then a 0. So now what you want to do, let's go ahead and factor out a sine x. Okay, because you can have a common sign. So you have 2 cosine of x minus 1 equals 0. Okay, so now you get sine x equals 0, and then 2 cosine of x minus 1 equals 0. All right, so now what we want to do is where exactly is this equal to 0? Okay, so that one's just going to be at 0 and at pi, and you can just go ahead and double check that. This guy, cosine of x equals to 1/2. Oh, we get the 1/2 again. Okay, so let's remind ourselves, where's cosine of x equal to 1/2? So remember cosine was the x, so that one was here at pi over 3. And then the other one was here, which was at 5 pi over 3. So pi over 3 and 5 pi over 3. Okay, and that's going to be my solution. All right, so we're almost done. Okay, so now we have this guy. So we have 9 cosine 2 theta is equal to 9 cosine squared theta minus 1. Okay, so what would this be equal to? So you have to be very careful with this one because, first of all, you have the cosine 2 theta. And with cosine 2 theta, it'll be easier to kind of make everything into a square. Now, the problem here is that with cosine 2 theta, you have two different things. Okay, so you have two different, how do you say it? Or you have three different trig identities. So which one would be the better one? Well, one of them has a sine and a cosine. So I don't think that one will be kind of really helpful. So instead, it would be better to convert the cosine into into just one cosine. So we're going to have 9. This guy, cosine 2 theta, is also equal to 2 cosine squared theta minus 1. Okay, so using the identity for cosine squared, then you have a 9 cosine squared theta minus 4. Okay, so let's distribute this, so you're going to have 18 cosine squared theta minus 9 equals 9 cosine squared theta minus 4. Okay, so I'm going to move the 9 cosine squared theta over. So then this guy's going to go away. I'm left with a 9 cosine squared theta minus 9 equals negative 4. Now let me add the 9 over. Okay, so that I can have all the numbers on one side. And then I'm going to take the negative 4, add the 9. That's going to give me a 5. So I'm going to have 9 cosine squared theta is equal to 5 over 9. Oh, no, wait. 5, and then we divide by 9. Okay, so now I'm going to divide by this 9. You're going to have cosine squared theta equals 5 ninths. Okay, then I'm going to take the square root to both sides. And I'm going to add plus or minus. So what I'm going to get is cosine theta is equal to plus or minus. Square root of 5 is going to stay the same, and then the square root of 9 is just going to give me 3. Okay, so now we have this equation that clearly is not on the unit circle. So we have these two solutions. Cosine of theta equals positive square root of 3 over 5, square root of 5 over 3, and then cosine of theta equals negative square root of 5 over 3. So we can find one solution because we know usually there's two solutions here. So here theta is basically looking at the cosine inverse of square root of 5 over 3. Okay, so what is that going to be? So let's go to our calculator. Let's put it in radians. And let's try to figure out where the cosine inverse of square root of 5. So I'm going to write square root of 5 and then divided by 3. So where is that going to be at? So that one is at 0.73 about. Okay, and the other one is going to be at, so cosine inverse of negative square root of 5 over 3. Okay, and that's going to give me about 2.41. Okay, so here are two solutions, okay, which are clearly within the range of 0 to 2 pi. Now, where's the other ones? Now, for the first one, let me change the color. Let me keep that one blue. Okay, so for the first one, well, where exactly is 0.73? Okay, so 0.73, if you think of all the positive values as all students take calculus, so that one is in this first quadrant. Okay, 0.73 is around here. Okay, where's the other positive one? Well, the other positive one is down here. Okay, so how do I get to this one? Okay, well, let's think about it. Well, let's try to use geometry. So this guy from here to here is 0.73, right? So that means this guy from here to here should also be 0.73. Now, if I do one whole revolution, that's going to give me 2 pi. So if I take this 2 pi and subtract it by this guy, you should get this other one. So that's what I'm going to do. So my theta, my next theta is going to be 2 pi subtracted by 0.73. And let's see what I get. Okay, so 2 pi minus 0.73. I'm going to get 5.55. That is my other angle. Okay, what about this guy? So 2.41. So 2.41 is not even pi yet. It's around here. Okay. So there's that one. So now what I want to do is I want to think about all students take calculus. Since it was negative, this is where this guy's at. So the other negative should be down here. So we know that this entire guy right here is 2.41. Okay, so how much is left over here? Because whatever's left over here is the same amount that's left over here. So So if I take pi minus, I'm going to take pi minus 2.41, you're going to get 0.73 right here. So that means that this amount is also going to be 0.73. So I'm going to take this pi, which is 180 degrees, and add it to this 0.73. So I'm going to take this pi plus 0.73, and that gives me a net other theta value, which is going to be 3.87. So that is my fourth solution. So theta in this case is going to be 0.73, 2.41, 3.87, and then 5.55. Okay? So obviously, if you wanted the all solutions, then you will add plus 2 pi k. Okay? So these problems are very straightforward, but if they're in the unit circle, they're pretty basic. If they're not in the unit circle, you do have to use a little bit of geometry, things that we've learned from the very beginning. Try to use some sort of the geometry, something about supplementary angles, and just basic symmetry. But other than that, expect these questions on the next exam.